Hi, welcome to an impromptu look at one of our older tools now, the PlayBasic to DLL. We released this for free recently, so it's on the forum. If you're logged in, you can come over to the forum and read the release history here. When you're logged in, you can follow the links to download it, those kind of things. There is a quite a long work in progress gallery about it as well that you really should read. There's no right way of putting it. You should read this stuff because that's why it's written. That's why we put this stuff on the forum. Um, it's not a joke. We expect you to read it. You might not understand it all, but hopefully you'll understand the thought process behind making these tools. So PlayBasic to DLL is exactly that. It converts your PlayBasic code into a machine code DLL file in what's called a Windows DLL file, or a dynamic link library if you really like the way that sounds. Windows uses DLLs all over the place. So the idea of these things is we take a bit of code we need to be fast or we need to reuse in other programs, and we compile this DLL from its normal source form into PB bytecode, and that PB bytecode is then translated to machine code. That's the general gist of this whole process. I'll assume you've already downloaded the file. I've got the PB to DLL archive up here. And really we just run the application. Now initially we have to run it to set this thing up. And what we need to do is we need to tell it where PlayBasic is. So it's saying that there's no valid compiler path because it doesn't know, it hasn't seen an obvious location for the compiler. So we hit locate. And what I do now is I locate the version of PB that I want to use. So it's going, okay, you found a version of it. Thank you very much. So our preferences are set. And that's actually all we need to do. Our next step is it's going to be writing, well, you can read the help files for some information about the tool itself. You can do this on your own time, really. You probably should do that then. Right, so we've initialized the tool. It's ready to use. Now, what we need to do is go to PlayBasic and write something we can convert to a DLL that's worthy of converting to a DLL. I've picked a particular favorite kind of thing here. This is a brute force operation. We're running through all the pixels on screen, computing a color at not at random, but incrementing the color and rendering it for every dot. If we just run it on this computer here, we can see the result of it. It's kind of an interesting looking effect. The colors will slowly scroll through. Right, so I've already saved this example. It's on the desktop over here. So I made a folder and saved our little project into here. So what if we wanted to really make this application run the best it possibly could? So we decided this section of code here would be better suited to running in machine code. Now, if we try and pass this piece of code here through to PB to DLL, it has no idea what it's looking at. So what we need to do first of all is build a function. And I'll grab this code here, and we'll make our own function. You know, we'll call it my fill screen or something. Complete that. Give the end function and place the code inside. What we probably should do here is we should actually allow the user to pass this fill color across, pass the fill color into the function. And we'll eliminate this code. And now in its place, we'll just call our function. So for those people who are not familiar with making functions or those kind of things, then jump in the manual, read this stuff, wrap your head around it, because I'm not going to go into that stuff. You either know it or you don't. If you don't know it, you probably need to go back and study this stuff up front. So we've built a version of this quite simple example that does this. I'll just grab a version of that. That was our starting version of this program. I'm going to be saving over it all the time, so I think we might want to keep these. Okay, so let's try and run the program, see what we've accomplished. We've accomplished nothing. Not a thing. We've taken a bit of code that was all one giant globule of code, and we've modularized it, if there's such a word, by taking the particular function or particular code that does the screen filling and made it into a function. But this is not really what PV to DLL needs. To make a DLL out of this function, we have to do two things. First of all, we have to have our source file that is made up of really just the functions we are going to expose to the user, or you can think of it like we're making our own commands. We need our functions that the user is going to use, and at the top we need our setup data. We can't have any do loops in it. This kind of do loop in global scope won't work. So to do that, what I would normally do actually is I would do something a bit different. Let's imagine that this is our main project. We've got a huge code base and then we decide we want to shift some of the workload from PlayBasics runtime into machine code to make our program perform better doing some brute force task. What I would do is I would create a new project, and we'll call this, I'm going to save it first. Where have we saved the other one? It's on the desktop, isn't it? Sorry, desktop. What do we call it? Fill screen demo. Very original. In here, I would make a folder for our new project, and we'll call this our. No, I'll just call it my DLL. How's that sound? That's our folder. Go into the folder, and we'll call this project as well. This is my DLL functions. You know, something descriptive so we can load this thing up later. Hit save, and that should be saved inside that folder. We'll just check. So now we see the fill screen project. We've got our normal files that PV creates. This is our code file. This is a backup of that file. This is the project files, the icon file. But we also have a new folder which has its own code file in there as well. This is going to be where we're going to place our DLL functions, and we're going to export and create our code. So here's what I would do. I've got my two projects open. I've got my big project over here, which we're just messing around with filling the screen. If I know I'm going to want to convert these things here across to DLLs, I would grab the function like so, cut that function across over into a DLL project. I'll just save that. Go back to here. Now I don't need this function in this section of code anymore. Obviously, if I try and run this piece of code, it's not going to work. That's because this function we just spent time creating and talking about, we've just removed it and moved it to an entirely separate project altogether. Now this is where we have to jump into our different mindset. So, sorry, go back to our DLL project over here. This is our DLL. This is going to be our DLL. This is what's going to be converted to a DLL that we're going to load into memory in our main project and call the machine code version of this function when it's created. Whole lot of gobbledygook. Now, if I run this code, we get nothing, and that's because it has no main loop in it, and it shouldn't have any main loops in it. If you need to set up data, you would do the data setup up here. Dim, an array or something like that you need. If I could spell it. Hey, it's late. Come on. You have these are global, so the functions inside here will be able to see this array, but when the DLL is created and you import this DLL back into your program, this will be invisible. The only thing it will be able to see is functions that have been exported and are visible to the end user. And the only way to do that is using the name prefix DLL. This really comes down to some stuff about how DLLs work in Windows, and it's a bit boring. But these machine code blobs of code, of functions, they can have a lot of code in them, but not all of it is exposed to be called externally. So you can think of it like a privacy layer, really. So some functions are exposed publicly, and which is what we're doing here, really. We're saying we want to declare this function publicly, and it'll expose a function called myFillScreen with one parameter to us. So if I save this, try and run it again, we should just go back to thing. Nothing exciting happens. Very good. That's what we wanted. We try and run the main application at the moment, we'll get an error because this function doesn't exist. Time to fire up PlayBasic to DLL. We know our library code, our example works. This is the key point. We're not doing this process all the time. We're writing our DLL functions. We're making sure they all work. Once we're happy, once we're satisfied that it does what it's meant to do, then we convert this thing to a DLL. That's how big applications are written. We're not constantly compiling everything all the time. No, it's just crazy. No one's got that much time on their hands. So we fire up the free version of this. Go to File, go to Convert File. Now I've got to find that thing we just we're messing around with, really. It's on the desktop. The project folder was called, fill screen demo. Now, if we pick main, we should get an error actually. We'll do that first of all. We'll show you this main file here is it's PlayBasic source code, but in that source code there are no functions with DLLs to be exported, so it should fail essentially. And there you go. It's giving us a compile error. It's giving us a rough approximation of the error. The array or function name myFillScreen is not defined, showing us the line compile aborted. So no DLL can be created from that piece of code because we've chosen the wrong piece. We need to go to this folder and now we pick main here. And that's the process. I'll just exit this now. Jump out of this. Go to fill screen. Into my DLL, which is where it was stored. Now we have two new files. We have a thing called unnamed DLL, which is what it just created, and a new include. Check it out. It's given us a linked DLL block that we can include in our main project that does this task. Let's see if it works. I haven't tried this for a while, so let's just see if it works. Back to PlayBasic. Right, that's the DLL project. We don't need that. What we need is our main project. So we need to include this source file. .pba. If we try and include it from here, we are including it from our fill screen demos location, and this should not work because we won't be able to locate it. Because I saved this file inside a folder inside that project. And that folder is called MyDLL. MyDLL, bit of a slash, that'll do us. So there we go. Oh, saying it can't find the DLL. That's what it's saying. Oh, geez. I hope it doesn't default to doing. We'll just check our include by opening up here. Unnamed. Yeah, that won't work. That doesn't work. Well, I could just cut and paste that across to here, really, couldn't we? Then we wouldn't need the include file at all. We can kind of see what's going on. So let's do that. Get rid of this include. Before it wasn't working, or I'm assuming it wasn't working because it was looking for a DLL called unnamed DLL in our fill screen project folder. And of course it's not there because we saved this thing over here. Hopefully it works. There you go. What do we got? So with a bit of messing around, we've doubled the frame rate of the example. Before it was running about 50 frames per second. We haven't done anything special really with it. Now, those people who know me would be going, well, geez, wasn't that fill screen routine using the fast dot command? And yeah, it does. Let's go to my DLL. What we'll keep this version of the function and we'll write another version. This time what we'll do is we'll myFill screen, we just call it 2, I don't care. This time what we need to do is we'll replace the fast dot. Now, even though it's called fast dot, internally dot is still doing, there's a multiplication for every pixel at least, addition everywhere. There's a lot of please and thank yous that go into calling a function. You know, there's a lot of work that goes into just doing something that's really simple. What we could do, if we get screen pointer, it's a bit of a misnomer here. We get the image pointer of surface 0, which is the screen. Pitch. Yeah, just call screen pitch. This is the number of bytes that occur on a row of pixels. We're assuming this function just fills the screen, by the way. It doesn't really allow for you to fill other surfaces. Now, I'm going to assume that the screen is set to 32-bit. We should actually here, we should check what type of screen it is and make sure that we are drawing to a 32-bit screen, but we're not going to. Let's be brave. Okay, so we've got our row color. What we need here is our row pointer. And row pointer is just going to equal screen pointer plus while loop times the pitch. So now, when we do a poke int. Poke int, row pointer, and row color. The translator will convert this, will inline this function completely, so it'll end up as pretty much a loaded store in memory. We do have to have an addition with row pointer. We could probably do it. Yeah, we could probably just do X loop and then shift it to 2 bits. As long as X loop's never negative, that'll work fine. So we're grabbing this value here, we're shifting it up, which is effectively the same as multiplying it by 4, adding it to the row pointer, and then writing this color into that piece of memory. Now we can't really test this. We can compile it. And it compiled okay, so I'm going to save that just to make sure. In this case here, what I tend to do when I do this kind of stuff is I split them apart. I'll get rid of that dealer, array. We don't need that, and we just call the function as a test here, sync wait queue, just to make sure that we haven't crashed it. It seems okay. We'll give this a different value and see what we get. Well, maybe not. Do we get the same result as the previous function? That's the question. We don't. So we've broken this piece of code quite convincingly. Well done. Okay, so what's wrong with this thing? Let's have a look. We've locked our buffer, we've grabbed a seed point from it, we've grabbed a pointer to the buffer here, and that looks like a fault. Look at that. We want to multiply the Y by the screen pitch, so we compute the first byte on the row. Not mask it. That's not going to work. Let's try it. Okay. I think we've fixed our little fault. Let's resave this stuff here. Just give it a quick test compile. Yeah, we're okay with that. Going to jump out and go back to Playbasic DLL. Normally I wouldn't. Normally I'd tweak the routine first and then build the DLL at the very end. But, you know, we can just go back to recent files. And this file here is the one we want to compile again or convert. So what it's doing is it's taking that source code, it's calling Playbasic to convert the text version of it into a compiled down bytecode. Then it's going through the bytecode and converting that to assembly and passing that through to the assembler to produce the DLL. So it's doing a bunch of stuff. Alrighty. Let's have a look at our folder. Let's create a new DLL, and our include will have a new declaration. This one here, that's our second function. I'll just be lazy and copy that across to our main project. I realise I'm probably being pretty confusing and obtuse for people, but unfortunately that's just the reality of it. Let's try something pretty daring. Text 1010, put some frame rate on the bottom. And what we'll do is that when we hold down space key or something, when this is false, we'll run the old version of it. Then we'll run the second version of it and we'll see what kind of difference in performance we're getting just from that one little shuffle of the logic. Let's try it. Okay, so we're getting about 109, somewhere in there, yeah, with the original version, and we're getting double the performance again. And all we did was just shuffle around some logic. I'll give you a hint, that's about the internal, like things like box routines inside PB, they're actually written in straight assembly. They're not written in C. And many are unrolled loops pretty much. And it's quicker than, that would be quicker than what we're doing in our little DLL. But let's face it, I mean, you can write extensions to your project in Playbasic, convert them to machine code, and it doesn't cost you a cent. You don't have to learn another language, you've just got to learn the process. I know it's awkward, you know, welcome to my world. This is what, the bigger these projects get, the more modular these projects get, it can be a bit of a nightmare. But anyway, hopefully that's gives you a bit of an insight of how you might go about structuring your project and how you might use PB to DLL to take the load off the PB runtime, and you know, win back some much needed performance if you really need this stuff. Okay, thanks for watching, and we'll hope you are successful, and we'll see you next time. Bye.